So when you did this coin flip, you can use the coin flip that you did for 605 if you want, although I think that was 100 times, but you can just cut everything in half, right? So I'm just going to make up some numbers here. They're all about as equally likely, right? So they should all be about 12 or 13. So I'm just going to go like 12, 13. Let's make this one 11, and then we'll make this one what? Wait, am I adding up right? Yeah, because I want to get 25. So then this one will be 14. Right? So let's say that's what I got when I did my coin flip. Based on your data, what's the experimental probability that the family has 2 dogs or 2 cats? There's that or, right? 2 dogs or 2 cats means that I consider both of those outcomes as favorable. So that would be, let's say that this is heads is dogs and tails is cats, right? So that means that I would look at this one and this one as both being favorable outcomes. 12 plus 14 gives me 26 out of 50. So based on the data, the experimental probability, it would be 26 out of 50. We could also write that as a percent by doubling, right? So
That's
we could write
50% chance.
Right. So when I look at your answers and I see something that's not close to half, something that's like 12% or 15%, some of you are even doing it separately. You're telling me, okay, the probability of 2 dogs is 12 out of 50. The probability of 2 cats is 14 out of 50. Okay, that's fine. But you have to put those 2 fractions together. You have to add them. So then you're still missing something from that question. So once you pick those 2 outcomes from your table, then you still have to do the addition. Okay, so number 4, you have to add the 2 probabilities together. All right, if the family has 3 pets, what's the theoretical probability they have 3 dogs or 3 cats? Okay, if the family has 3 pets. So now this is a little different, right? Let's think of all the ways that we could get 3 pets, right? So we're basically talking heads and tails. So we could have 3 dogs, right? Or we could have 2 dogs, but there are quite a few ways that we could have 2 dogs, right? You could have a dog, and a cat.
A cat, a dog, and a dog.
Cat, a dog, and a dog. Or a dog, a cat, and a dog, right? Then you could have, so these are all the ways you could have 2 dogs, right? This is the way that you could have 3 dogs. So now we're going to look at how many different ways could you just have 1 dog? And that dog could be first, it could be second, or it could be third, right? Those are all the ways you could have just 1 dog. And
yeah, so it's basically just looking for the possibilities, right? Probabilities.
Right. All the
It's like-
possible outcomes.
Yeah.
Then, of course, you could have 0 dogs, right? And just all cats. So that would be cat, cat, cat. 0 dogs, right? So that's it.
Meow.
So for some of you who answered this question incorrectly the first time around, my advice was maybe write out the sample space, which is what I just did here. Because if you write out the sample space, you can see how many outcomes there are total. And then how many are either 3 dogs or 3 cats, right? So if I add them all together and I want to know how many total outcomes I've got, count them. Let's just count them. I've got 1, 2, 3, 4, 5, 6, 7, 8, right? I've got 8 total outcomes. So out of those 8, how many are 3 dogs or 3 cats? This one and this one. And again, because it says the word or, I'm going to add them together, right? This has a 1/8 probability. This has a 1/8 probability. Each one of them has a 1/8 probability, right? So the probability I'm going to have 3 dogs or 3 cats would be 2/8 or 1/4. What's the probability that I'm going to have 2 dogs? Someone want to answer that? What's the probability I'm going to have 2 dogs?
3 out of 8.
Right, because I've got 2 dogs in
3 probabilities.
3 out of 8 outcomes. Okay? What's the probability? Here's another one. What's the probability I'm going to have at least 2 dogs?
4, right?
Yes, 4
'Cause
out
it's
of 8.
at least. Because
At
there's
least
at least 2
dogs.
dogs.
Means
And there's
everything
3.
above here, right? All those outcomes are at least 2 dogs. And that's 4 out of 8 or 1/2.
Mm-hmm.
All right. I could have also said, what's the probability I'm going to have 2 or 3 dogs, right? That would give you the same 4 results. It would still be 1/2. And then finally, the last question is, how would you change the simulation to generate data for 3 pets? Well, it's pretty clear from our sample space, we would need 3 coins, right? We would need tails or heads, tails or heads, tails or heads. So we would need 3 coins if we wanted to simulate this experiment. Okay. Any questions on 703?
No.
No.
All right. Great.
N to the O.
All right. I'm going to stop recording now.